You're listening to Sweet Talk, all things maple. Welcome back to Sweet Talk. I'm your host, Adam Wild.
And I'm Aaron Whiteman.
And we are co-directors of the Cornell Maple Program at Cornell University. As many of our listeners know, a real passion for both of us is maple research. But oftentimes the question we ask each other in the maple industry this time of the year is, how was your maple production season? But for the both of us, hitting our research goals is really actually more important than production numbers. So now that 2023 maple season is wrapped up, how was your maple research season this year?
Well, maple season is such a short time frame for conducting experiments and collecting data, and it can get chaotic when there are so many other things keeping us busy in the sugar house and in the woods. But we learned a few things this year that we hope to share in the future. How about your research season, Adam? Did you complete all your experiments?
Well, it was a short maple season in the North Country, and it felt like it ended just as I was getting started, but nonetheless, I was able to collect great data, so I would consider it a productive maple research season overall. I was able to learn a few things on different projects, and I hope to share about those in some future Sweet Talk episodes.
Well, that's great to hear, Adam. It really is exciting to experiment with different techniques and try new things that could help improve maple syrup production, and then share those results with our listeners. And often those techniques are the culmination of multiple seasons of testing, sharing ideas with other researchers, and building on the work of others, both those that came before us and our colleagues at other institutions.
Yeah, and speaking of folks who have done a lot for the industry, I had the chance to interview Dr. Tim Perkins before he recently retired as director of the University of Vermont's Proctor Maple Research Center.
Dr. Perkins has been a key figure in maple research for almost 30 years. And I'm looking forward to hearing what he had to say about his time working within the maple industry and where he sees it heading in the future. Let's have a listen.
Hello, Tim. Welcome back to Sweet Talk.
Thank you for having me.
So today I want to talk a little bit about your experience within the maple industry. So you're coming up on your retirement from the Proctor Maple Research Center. So how many years have you worked at the Proctor Maple Research Center?
Oh, I've been there since 1996. So whatever the math is.
All right, great. And how did you get started working within the maple industry?
I actually grew up sugaring very young, working on my grandfather's farm with my uncle and father, and basically the whole family pitched in. Some of my earliest memories are in the sugar house. When I went to college, I studied ecology, forestry, and after I finished my degrees, I worked in forest research, looking at the physiology of spruce trees. When Dr. Mel Tyree, the previous director of the Proctor Center, stepped down, they asked me to serve in his place.
Was that a big jump from spruce to working with maple, or having that background growing up that it wasn't too crazy?
I'd at least had some background, and they wouldn't change the name of the place to the Proctor Spruce Research Center, so I had to change my focus a little bit and work on maple physiology, but it's still trees. It's still something I enjoyed doing, so it wasn't too much of a stretch.
Yeah, the folks in Vermont probably wouldn't get too excited about spruce syrup.
Some would maybe, but probably not a lot.
Describe to me what it was like, in 1996 when you started working at the Proctor Maple Research Center. What was the type of technology and equipment and type of research that was happening at that time?
The technology at the time was similar to what we have now, but an earlier generation. So that was just about the time that small spouts were coming out. So most people were still using 7/16" spouts. A lot of them were still using PVC tubing, the real kind of stretchy stuff. A lot of taps on a lateral line, vacuum pumps that were mostly old dairy pumps that had been adapted with homemade releasers. Releasers are just starting to be something that a lot of people were using. So, and tubing system design was different as well, not nearly as well adapted to high yield collection as it is now.
Was the tubing, was that laying on the ground mostly at that time, or was it actually suspended?
No, at that time it was all suspended. So it was similar to what we have now, but just tended to be quite a bit smaller diameter. People use 1/2-inch lines, 3/4-inch lines, not a lot. That was a whole much bigger, many taps on lateral line. So maybe, 10 to 20 to 30 taps per lateral line on vacuum. Vacuum levels were maybe 15, 18, 20 inches at best. All the systems really just hadn't been optimized. They were getting better and better. The spouts that were being used were all 7/16 for the most part, and very little or no sanitation done at that time. So people would just reuse the same spouts each year, plug them. Some people might wash with water or chlorine. People were moving away from chlorine due to the squirrel problems, but not a lot of other sanitation of tubing systems going on at that time, and spouts were just reused year after year after year.
Do you remember what the production was per tap at that point?
For until we retubed our entire sugar bush in 2004, we had probably 30 years of records on the previous system. So that was low vacuum, large spouts. If we had a year that hit 0.3, 0.35 gallons per tap, that was a great year. That was a banner year. Average was probably down around a quart per tap, which really wasn't much better than what you'd achieve on gravity.
Mm-hmm. And probably comparable across the industry, you would say, at that time?
Yeah, I would say it was similar. Yeah.
What were some of your earliest research projects that you remember doing when you first started there?
Some of the earliest things were looking at the new small spouts that had just come out in 96, 97. They came out, and we started looking at what the yields were on gravity, and then a little bit later on vacuum, trying to compare what the tap hole depths should be. A few years later, we started looking more at what different levels of vacuum how that would influence sap yields. And we've been continuing sort of along the same lines of trying to figure out what all the different parameters are at different vacuum levels and different sanitation levels.
What are some of what would you consider kind of the biggest changes to the maple industry within your time of working within the research world of maple that has really kind of pushed the maple industry forward?
Yeah, I don't know that there's been a whole lot of real super revolutionary things. It's been a lot of evolution. So maybe the biggest thing was the change from the large spouts to the small spouts, because that did change sort of all of the other parameters around that. It made it possible to have tubing systems that were a lot tighter. And once they could be tight, then everything else could be adapted to work better. So better tubing, better fittings, everything became much more leak-free. Vacuum pumps got better and better. The releasers got better and better. And then once we found that, we started looking at how to optimize the systems in terms of number of taps on a lateral line once we could get good vacuum. And then from there, it led into sanitation and other sorts of issues that have just sort of continued to move the yield curve higher and higher over the years.
And what would be some of your proudest contributions to the maple industry that you've been able to make over your years?
I think some of the larger contributions have been along the lines of how sanitation impacts yield as well as vacuum. Largely, a lot of the factors that go into determining how to get high yields and what the trade-offs are between yield and economics. We've had a lot of, as I said, revolutionary things. The things I enjoy the most are trying to come up with new types of devices that could optimize sap yields from trees. So things like the check valve spout or the new barb spout, those things are exciting to me in terms of trying to identify first what the problem is, and then trying to find ways to solve it.
Yeah, kind of being creative and kind of to tinker around and try new things.
Yeah,
right?
I enjoy those types of things, and there are a lot of successes, but a lot of misses as well. So we learn from each of those types of things, whether we hit it squarely or miss at times. We learn.
That's great. And, like you mentioned the check valve spout, and a lot of folks would attribute that with your work, which is a big impact. But are there any kind of more lesser known contributions that people may not recognize that are, whether it's just, little simple things such as, updating the Jones rule of 86, of how we calculate sap to CRP ratio or other things?
Yeah, it's hard to put my finger on any one or two of those types of things. There's been so many over the years. But one thing that people probably don't pay enough attention to is the sustainability aspects of maple, and that a lot of the things that we would recommend are things that we have first tried to think about whether or not they're sustainable in the long term, and that we would either moderate or hold back on recommendations until we fully understand what the consequences are of some of those decisions. So we have to be a little bit careful when we talk about some of the research, especially some of the newer things that we work on. We don't really want to introduce it really quickly until we have a good understanding. And that sort of leads to a little bit of consternation for both us and the producers. They want to hear about the new stuff, but we try to not really be too aggressive in pushing them in a direction until we completely understand all the different consequences.
Because it takes a few years to kind of look at some of those things, right?
It does. And especially because each season is a little different.
Yeah.
So we'd like to get, if we can, 2 or 3 years of research under our belts before we talk a lot about something. We may introduce it, but we don't like to put it in writing for a few years. So oftentimes we'll introduce some of those new things in our talks and see what kind of questions we get from people and what sort of comments we get. And then after we've done a few years and chatted about it a bit in presentations or in conversations with other researchers or producers, then we'll put it in writing and put it out in the Maple Digest or Maple News or some other venue.
Yeah, I like to think of, it's challenging with maples, unlike, say, growing like corn, where you're going to plant it, you can research it, and then harvest it that year, right? Where these maple trees are slow, they're slow growing. We're tapping these older trees that are very slow to respond to various changes, right?
That's true. If we make mistakes that are hugely consequential, then that's a bad thing. So we tend to be a little bit cautious in making recommendations. We like to say that we can do the weird things so the maple producers don't have to. If we make mistakes in our woods, it's okay.
Yeah, it may impact the future research, but it is okay. It's
Right.
a lot better happening to our woods than somebody's business, right?
Right.
So you mentioned that, when you first started, some of the questions were, looking at that smaller tap hole size. So fast forwarding now to kind of present day, what are the research questions now? How has the maple research changed?
I think they largely remain very similar in that we're still looking at things that affect yield, but we're trying to incorporate more and more the issue of sustainability, in particular the long-term sustainability. We have a pretty good idea how tapping affects wounding and various practices affect wounding. So how different depths and size of tap hole affects it. But what we don't really have a great handle on is how the long-term removal of sugar, which is energy that the tree is storing for its own use, but if we're removing a portion of that, how does that impact the tree over the long term? And so that's a question that we've thought about for a long time and have been studying for a long time, but haven't really come out with our results yet. We're getting to the first point in what we consider the end of the long-term study. So it's a 10-year study looking at how different levels of carbohydrate removal, sugar removal from trees affects growth. Growth is a factor that incorporates total health of the tree. So we're looking at how various levels of sugar extraction, from none to low levels using gravity to high levels using high vacuum, and how that affects the growth over a long period of time. And this is our 10th year of doing that. And that was the sort of the minimum time frame we wanted to look at. And so in October, we'll have the growth data for that 10th year and then be able to talk about it more. And, you think about it, 10 years is a really long term. In a research study, usually 2-3 years is about all you can get. So 10 years is a very long term. But for a maple tree, 10 years is nothing. Mm-hmm. A maple tree can be 200, 250 years old. So even though we think of it as a long-term study, it's a very small snapshot in the life of a tree.
Yeah. So do you think 10 years is enough? Is that something that you think you'll continue to monitor, or folks after you will continue to monitor?
I suspect that study will continue for a long time after I retire, but that remains to be seen.
How will we if it comes out in 10, 12, 15 years that high vacuum is impacting the carbohydrate pool within maples and their growth rates and overall health, how do we respond to that? Do we need to back off on vacuum or how we tap trees?
I think that will have to be a decision that's made based upon what the results are. It's going to be difficult to interpret anyway, because if we see a huge difference, and the preliminary results don't indicate that's a huge difference, but if there were a huge difference, then I think it would probably require some drastic change in our practices. But if it's a really small difference, we have to determine whether or not that is biologically significant. Does it matter if we reduce the growth of the tree by 5% over a 10-year time frame? Maybe, maybe not. Maybe that's the trade-off between what we're doing and the growth of the tree. So there'd be some level of interpretation that has to be applied.
And maybe there's some more active management that needs to go into our forest then, or something, whether it's nutrient
Certainly.
additions or liming or just making sure we have good regeneration and new ingrowth.
Right.
So if that tree may live 10 years less, but
yeah. So again, if we go back to that and say, well, if there were 5% reduction, could we offset that by being a little more aggressive in our management activities or fertilization or some other approach? But we'll know better in October.
Sounds like that leaves some more areas of research in my future, right?
Well, that's important for us as researchers, not to answer all the questions, because we want to keep our jobs.
That's right. Recently, you were quoted in the Maple News for saying, you think it's easy for us to be able to gather a gallon of syrup per tap. So is that accurate? And, what are some of the changes that you think we need to make to get to that point?
I think what I said was it's possible to get a gallon per tap in some occasions. I don't know that it's necessarily easy. You have to do things right. You have to have the right kind of season. You can't make any mistakes. It certainly is a possibility. We've certainly done that on many individual trees. It isn't any great secret. It's really good vacuum, really good sanitation. Don't make any mistakes tapping. Keep everything really tight. Keep your vacuum as high and as constant as possible, and make sure you tap early enough, but not too early. So it's possible. Trying to push that yield higher and higher each year, I think eventually there is a little more room for us to improve yields by doing different things, and that's why we're starting to look at some of these other types of spouts and fittings to try to do that. There's a little more room. I don't know that there's a lot more room in doing that. We'll see. The next 10 years will tell us whether or not we can continue to push that higher.
Yeah, again, more areas of research, right? And forgive me for saying easy, because that was not the correct word. The possibility was definitely the correct word.
I definitely think it's a possibility. We do see it in some research studies that we're able to do that, and it just takes a lot of care, a lot of attention to detail. It's important that when we recommend certain things, though, that we also do it in a way that's economically feasible. We can do it. It's in the realm of possibility, but can we do it economically in a way that maple producers are going to be able to replicate?
Yeah, exactly. You could go out there and put a brand new spout on every day, but that's not feasible, right?
Right.
So speaking of, looking at the next 10 years, where do you see the maple industry heading in the next 10, 20 years?
I've never had a real good crystal ball that wasn't cloudy, so it's hard to say. But I think we will continue to see better and better yields as people adopt more efficient practices and make fewer and fewer little mistakes. And that's kind of one area that I don't think people pay enough attention to. Is people are really good at doing high vacuum, good sanitation, but it's these little mistakes that sort of creep in when you're tapping or doing various things, tapping into stained wood or making slightly oval tap holes or overdriving spouts. All of those things add up. And when you do enough of those, or you do them to the point where you're overdoing them, then you've gone beyond the point where you're getting good yields and you've started to reduce your yields again. So I think that's probably one of the places for education at this point, is making sure people understand that they can not only improve their yields in certain ways, but they can also reduce their yields if they do things wrong.
What do you think will be some of the challenges to the maple industry moving forward?
The challenge, at least on the US side, has always been having economics that are stable. So maintaining a stable price for syrup. It's very helpful that the Federation in Quebec has a price that they maintain each year that sort of provides a floor level for maple syrup in the US. But there's still this sort of up and down that happens that's dependent upon supply to some degree, also moderated by the Federation. But in the US, with a free market system, our prices can change. And if prices drop too low, then it becomes more difficult for people to use some of the high yield techniques. If prices go too high, then syrup sales drop and the prices will drop again consequently. So having that price be really stable is helpful, but we aren't quite there in the US yet.
Mm-hmm. A question for you that I'm sure you get all the time, I get all the time, especially this time of the year when the different reporters are calling up is, asking about how does climate change impact the maple industry, right? And so thinking about, over your time at the Proctor Maple Research Center, have you seen any noticeable differences within the environment, the climate?
Yeah, it's always difficult when we get calls from reporters or from individuals asking about climate change because we could extend this topic into 3 or 4 interviews very easily. And usually people just want the quick answer. And with climate change, there is no quick answer. It's a very complex issue, multifaceted in terms of how it impacts maple. And so, it has had an influence on the maple industry already. Just within my lifetime, I can see the season is starting earlier. We have records that show the season, on average, is starting earlier. That's not true every year, but on average, the season has started earlier and earlier every decade. And for a long period of time, up until about 2010, the season duration had also been shrinking. After about 2010, when we started doing all this research, and Cornell did as well on sanitation, we actually reversed that trend and made it so season duration got longer because we were able to keep tap holes viable for a longer period of time through really good sanitation. So we almost completely negated the impacts of climate change up to that point on the duration, not on the timing, but on the duration. That can't go on forever. As climate change continues to happen and warming goes on, we're going to see eventually a reduction in the duration again. When that happens is very, very hard to tell. Projections for climate change vary widely. So whether we have a low emission or a high emission scenario and how those effects, when they start to really hit us, is difficult to predict, but they will come. And they're going to be seen first, particularly in the southern edges of the maple industry range. So places like West Virginia, Ohio, Illinois, places that don't traditionally make a lot of syrup, but still are engaged in the commercial maple industry. They're going to see it, and they are seeing it now. They have some years that are just disastrous, gets hot very quickly. So over the next 20 to 50 years, we're probably going to see losses in those types of areas. To say that some people high up in the hills won't still be making syrup, but it'll be harder and harder for them to sustain a commercial maple industry. And that sort of trend is going to move northward. The rate it moves northward depends upon how fast climate change happens in this area.
Yeah, and I know it's a very loaded question, and like you said, we could spend many episodes on that, and maybe that will be some future topics. But those are great answers. And I think as an industry, we need to learn to adapt, and that's my kind of outlook at it too. Is looking at future research is being able to adapt to those challenges. So
absolutely, and that's part of our job is helping the industry face those challenges and understand how to deal with them if we can.
Yep. Yeah. But you certainly can't just look at one, year like this year or 2021 or 2012 as one data point, right? And
no, it's really necessary to look at a long period of time, as long as we can get, and that's good. It's also important to note that when you see all these gloom and doom scenarios, there may be years that it's just a terrible year for some reason, but they've had terrible years since sugaring started. they're always going to crop up. We can't point at them and say that is an effect of climate change. If we get a lot of them in a shorter period of time, then we may be able to say that. But at this point, it's difficult to say that.
Yeah, like, for the 2023 maple season, it started kind of early in northern Vermont, northern New York, and that was kind of the report going out, and then it got cold and kind of held off. And so
Right.
then it's just kind of like one of those, it just can't look at one single year.
But the overall trend is that it's going to get warmer. Seasons are going to be different, and we have to adapt to them.
Yeah, great summary there. What will you miss about maple research and working within the maple industry when you retire?
I think the people, the people are a really interesting group. They tend to be very inventive, very creative, come up with a lot of interesting ideas. And maple sugaring is oftentimes a very social activity, very family-oriented activity. And so you get to meet a lot of fun people and hear a lot of interesting questions. Some of them spend a lot of time thinking about how to make the process better as they're boiling. So good conversations, good people.
Are there any kind of larger, memorable kind of mistakes that you tried that just did not work out? You kind of mentioned this before that, you've made mistakes, but is there one in particular that you may want to reflect on?
We've tried a lot of things in terms of maple tubing, and probably one of the mistakes that we made, which seemed really good on paper, was going to larger size lateral lines. So 1/2 inch instead of 5/16. And in terms of calculations, worked great. It could potentially work quite well in the field. The problem is it's just large enough that the tubing is too heavy, so that especially when it fills with liquid, it sags. So then that negates the fact that the tubing is bigger and can transmit more sap and better vacuum transfer. It would work if you suspended it on wire, but then at that point it becomes not economically viable. So we did some work with that for a few years, and it just didn't turn out to be something that we could easily make work in an economical fashion.
Yeah, that's interesting to hear, but it was probably fun to try that and play around with that, though.
It was frustrating too that we couldn't make it work because it seemed like it could have. But that's we learn. As I said, we learn from the good things. We learn from the mistakes too.
What are some of your most memorable moments of maple research, or maybe it's even not the most exciting of getting, nasty sap dumped on you or something, or is there something more memorable?
Yeah, it seems like every year, we talk about trying to minimize mistakes, but there's always syrup that you always end up being covered in syrup at some point during the year, sap, syrup, or any
or all
anything.
the above.
So we do have times like that happens, and you just kind of have to laugh. It's going to happen. But probably the things I enjoy the most are for us at the Proctor Center is a tradition of we sit down at lunch together every day. And if people are out in the woods, if they're close enough, they come in at lunchtime. We sit down, we take 45 minutes or an hour, and we talk about things that we're doing, questions that we've had, questions we're thinking about, and everybody just joins in and gives their ideas. And so we take those when we go back out in the woods and we start thinking about what did everybody else say. And so it's a collective coming up with new ideas and new approaches and thoughts. And at times the arguments, being scientists, we're sort of professional arguers. So the arguments at times get pretty, I wouldn't say heated, but at least intense. And it makes us want to go out and do the work even harder and faster and try to get those answers so that we have more things to talk about and can settle those arguments. And so that's fun. I'll miss those kind of interactions.
Great. Yeah, that sounds fun. And when you go back out in the woods, it's a great time to think, right?
It is, certainly.
Yeah. Great. Well, thank you so much, Jim. I really enjoy that you took the time to meet with me today, and I really appreciate all the many contributions to the maple industry. The maple industry owes you a debt of gratitude for pushing the industry forward.
Well, thank you. I've had a fun time of it.
Great. Well, thank you, Tim. Enjoy your retirement.
Thank you.
Well, Aaron, sometimes it's good to take a step back and look at how things are changed, and then look forward to where we're heading in the future. So, as a fellow maple researcher, was there anything Tim mentioned that really resonated with you?
Yeah, I think the fact that he mentioned that this is really a cumulative effort over time, that we've been slowly making improvements over the past few decades, especially to arrive at the point we're at now. I've been making syrup long enough to have spent days out in the woods with a brace and bit, tapping that way, doing 7/16-inch tap holes and hanging buckets or using the old PVC tubing. And here we are not too far from that, not too many years in the future with these really advanced systems. But that change took place slowly over time with lots of little innovations. And that's just interesting to me that we were able to contribute these little bits and pieces that have come together into a profitable industry.
Yeah, I think it is interesting to look back and see how the industry used to be not all that long ago. Out there in old wooden snowshoes and tapping with either a brace and bit or gas powered backpack tapper. And nowadays I can control my reverse osmosis from my cell phone from the comfort of home. And, the industry has really changed from the technology, but also the research that's been done by folks like Tim Perkins and those before him as well.
Yeah, and some of that really isn't all that obvious. Things that we wouldn't think of ourselves in the woods, perhaps, that Dr. Perkins latched onto, and problems he solved, like tap hole sanitation. This idea that maple trees go into a vacuum cycle and suck microbe-laden sap back into the tap hole, which contributes to faster tap hole closure. That's pretty important. And that's something that he looked at and really persistently worked at and found solutions for. So those are the types of things that researchers have contributed, and we're really grateful to be able to build on that body of work to advance to kind of the next level where we maximize sap production in the woods.
Yeah, and we continue to look at those little tweaks to our system, right? We're not always making these big groundbreaking discoveries, but building upon little things, where little issues, how can we solve some of those problems to optimize that production overall. But, it takes multiple years of doing that. We can't just look at one individual season.
Yeah, and I really appreciated that Dr. Perkins shared that point. I've made that mistake as a young researcher early on, that we tried something in the woods and it seemed like it worked, and feeling compelled to go out and tell everybody about it and being excited about it. But it's really important to take time and multiple seasons to see, does it work from year to year under various conditions? What are the impacts, especially when we're dealing with trees? We need to think really carefully about impacts to tree health, or when there are potentially food safety issues. What are the implications there? So we do have to proceed with some caution as researchers and really take our time and vet these new ideas very thoroughly before we make any sort of recommendations or report our findings.
Yeah, it is hard, especially with maple trees, that they're so slow to respond. They're these big sponges, so they don't respond as quickly like some of our annual crops of other agricultural commodities that are out there. So it is definitely a challenge, but it adds some more fun to our job as well.
Yeah, that's true. And just one more note on that topic. Yeah, if we mess up our maple trees, we can't just go plant a new sugar bush. So it would be great if we could.
You can. It just takes time, right?
That's right. That's right.
Yeah, and I think Dr. Perkins brought up a good point in thinking about our maple industry and how climate change is, impacting that, and how as an industry we really need to adapt. And, we're potentially going to have a shorter season, so how can we collect more sap within that shorter time frame? I think it's going to be really important as we look forward.
Yeah, and we've kind of reached this plateau, maybe this point of diminishing returns with the new technology. We've kind of created these systems that are pretty darn effective, and there aren't a lot of big problems left to solve. But this new challenge of climate change is certainly something that we need to address. So that's the next thing on the project board, is really drilling down and figuring out what we need to do differently as we have warmer and warmer sugaring seasons. And that way we can stay productive, at least for a little while, even though the weather gets warmer.
Yeah, definitely. And, he even alluded to how some of that work that our predecessors have done that has helped to where we're at a production point now where we don't see as much impacts from climate change. But as you said, those are things that are going to keep us busy and keep us employed by continuing to look into those areas that we can really hone in on, optimizing and keeping good quality products in warmer weather.
Yep. Topics like sanitation, improving our tapping timing and practices, maintaining high vacuum, all those things are things we're going to have to look at more in the future, and maybe some things we haven't thought of yet.
Yeah, for sure. And I think that's just going to keep us busy. Job security for us, I guess, right?
That's right. That's important. As long as the grant money keeps flowing, we'll keep investigating.
Exactly. But for now, we wish Dr. Perkins well in his retirement.
Yeah, and I'll second that. Congratulations on your retirement, Dr. Perkins, and thanks for all your contributions to maple research. And we really look forward to continuing to work with all the folks at the University of Vermont in the future.
Join us next time for more Sweet Talk, all things maple. Thank you for joining us for Sweet Talk, all things maple with Aaron and Adam. Sweet Talk is produced by the Cornell Maple Program and is made possible from funding from the USDA National Institute of Food and Agriculture. All music was obtained from Blue Dot Sessions. For more information on all things maple, visit cornellmaple.com. Join us next time for more Maple Sweet Talk. Have a sweet day.